Okay, hello again. As I stated at the end of the last lecture, I wanted to go over the experimental design assignment. I do apologize first. Looking at questions 1 and 2, you should have referenced chapter 8 for those particular questions, so we'll get to those in a little bit. I want to first go over the chart and questions 3 through 7. So for the chart and the experimental design portion of this assignment, the following data represents information collected from a research methods class. Students in this class took a pre-test on the first day of class. They took the exact same test on the final day of class to gauge their improvement in the teaching effectiveness of the professor. Use this chart to answer the questions. Okay. Excuse me. Okay. What we want to do here is answer these particular questions. Now, this is a scenario that I mentioned at the end of the last lecture, at the end of the last video. So we have students, let's say 30 of them, enrolled in a research methods class, and we want them, we want to gauge, of course, how the actual class affects things, or affects their knowledge of research methods. So here, of course, we have 10 observations, 10 students, and we have some of their demographic information. Of course, information that we don't know is significant. Of course, what would affect, the post-test, study habits, employment, are they involved in extracurricular activities? But we don't have to worry about that portion of it. So what we get from this particular statement is an answer to number 3. What is the treatment effect? What is the treatment in this experiment? It is taking the course. The research methods course in the 16-week semester is the treatment to this particular experiment. The control group, and this is where it gets tricky, the control group of the experiment are the students during the pretest. So essentially, it's the pretest scores. Because although the same students take the post-test, like I said in the last video, the students haven't been manipulated yet, or they haven't gone through the treatment. So the same students effectively act as the control group and then the experimental group. So you're getting control group scores here in the pretest, experimental scores here in the post-test. So what is the experimental group in this scenario? It's the post-test, or of course the students after the 16-week research methods course. Now, what is the treatment effect in this scenario? Looking at the treatment effect, we of course want to know the effect taking a research methods course has on students' knowledge of research methods, or in a sense, how well they did on the post-test. The treatment effect is, for the most part, a qualitative statement. And the effect size is a quantitative statement. So you really need to do 6 and 7 together by doing the math on the difference between the post-test or the pre-test average and the post-test average. So what we're looking for, and let me pull up another sheet here. Sorry, I'll make this a little bigger. So let's zoom this to 130. Make it a little bigger. And let's look at 6 and 7. So by doing them simultaneously, you're going to want to do you're going to want to figure the difference between the post-test score or the pre-test scores and the post-test scores. So going down to number 7 kind of gives you an explanation for this. The effect size is the quantitative difference between the control group and the treatment group. To calculate the effect size, take the average of the pre-test scores. So add these 10 numbers up and divide by 10. Do the same with the post-test scores. Add these numbers up, divide by 10. what we get here is the pretest scores, the average is 33%, 0.33. The post-test scores are 80.5%, 0.805. And then all we need to do then is to subtract the pretest score or the post-test score, or subtract the pretest scores from the post-test scores. Here's the equation: 0.805 minus 0.33 equals 0.475. Now then, to answer the questions, the treatment effect then in this particular scenario is taking research methods course increase students' knowledge of research methods, or something to that effect. So by taking a research methods class, one will improve their knowledge of research methods. Now, it's possible in another scenario where going through a treatment might decrease a situation. And of course, when we talk about recidivism and going through treatment, say in the past video, drug court programs may decrease recidivism. But in this particular scenario, it's increased knowledge of research methods. We know that because 80.5% is greater than 33% between the average scores of the pretest and the post-test. The effect size is the quantitative number. So in this, when you do the math, the final number is 47.5%. So taking the research methods class improved students' knowledge of research methods by 47.5%. So it is that particular number. And let me give you kind of a scenario in which kind of crystallizes the idea of why it's important. Okay, we want to know the treatment effect, but why do we want to know the effect size? The treatment effect will tell us that will increase one's knowledge. However, let's say that instead of 0.805, it was 0.35. So persons on the pre-test averaged 33% on that test. Students on the post-test averaged 35%. So this statement is still true. Taking the research methods course did increase the knowledge of research methods. However, doing the math, it only increased it by 2%. So it gives you a more precise indication of how well the course did in improving individuals' research method scores. So put it in a practical sense. Let's say you paid $4,000 for this particular course, and I don't know what courses exactly cost. Probably not that much, but let's just say it is. So 4%. So are you willing to spend $4,000 on a course to improve your knowledge by 47.5%? And if so, are you really willing to spend $4,000 to increase your research methods knowledge by 2%? So knowing the exact effect size is very important, because you're not likely to pay $4,000 to increase your knowledge by 2%. That's hardly a significant amount. So that's why we really want to know the effect size. So understand that 6 and 7, they go together. 6 is a qualitative statement, but 7 gives you precision to that qualitative statement. So you want the exact number. Okay, looking at these two particular scenarios. So in this particular video, based on the fact that it can only be 15 minutes long, we'll go through the first question. Using the sampling frame, how could you systematically sample Ball State students for the study while also maintaining equal probability of selection method? The idea of equal probability selection method, and I'm going to switch this over, is that when you begin your sampling process, you want everyone within your target population who you're going to study to have an equal chance of being selected at random. So here we are, our target population is Ball State students. So that's about 17,000 undergrads. So that's our target population. We want to draw a sample from that randomly and maintaining the idea of equal probability. So in systematic sampling, we can do so. Systematic sampling is just one particular method in which to randomly draw a sample from a larger population. So specifically here, we have a sampling frame. That is a list of our target population. I know within these two particular chapters 7 and 8 that some of our terminology gets kind of turned on its head. Sampling frame is a list of the target population. The sampling element is our target population. Imagine a sampling frame of Ball State students. I always imagine it as a printout of a list of 17,000 students' names on a piece of paper, and putting that or rolling that piece of paper, which would be very long, down McKinley Avenue there on Ball State's campus. Then you have this spread out sheet of 17,000 names on it. So that's our sampling frame. Now, of course, realistically, that sampling frame is just in a computer. But let's imagine as a physical list. To systematically sample that, let's say then we have, we want to draw a sample of 1,000. So what we want to do then at the beginning of our method or our sampling process, we want to take, put in a hat, if you will, numbers through 1 through 17. And randomly draw one number. And let's say you draw number 8 on that. Okay, so then you start with the number, the 8th person on that list, that physical list that's rolled out on McKinley, all right, in your sampling frame. You start with number 8, and then you sample, let's say, every 100 from that. So you grab number 8, number 108, number 208, number 308. So at the beginning of your sampling process, everyone had an equal chance of being selected. Now, once you randomly drew that number 8 to start with student 8 on the list, not everybody had an equal chance, but that's okay. You began, you began with equal probability. That's essentially systematic sampling. Now look on the PowerPoints and you will see that we want to avoid one problem within systematic sampling, and that's periodicity, in which by chance whatever number we randomly drew, say the number 8, doesn't pick up some other pattern. Incidentally, choosing individuals, say in class, and the way they're lined up in rows, and you choose a number 1, which gets every first person in each row. Well, sometimes in my particular classes, athletes sit in the front rows because their coaches require it. Subsequently, my entire sample is then made up of athletes. That's something I did not account for, and does, of course, bias the sample. But of course, in our initial scenario with sampling frame rolled out into McKinley Avenue, periodicity isn't really going to be a huge issue, assuming it's done in alphabetical order. Or, I mean, I guess it can be in any particular order, class standing or whatever, because you will eventually hit those. But you don't want some actual reason why individuals are placed in the sampling frame, so you don't oversample a particular population. So if you take a look, and my time's about to run out, this has, and I will obviously post this, this has an explanation of course, what we just went over, and how you would use systematic sampling in this particular sample. The issue really becomes when we don't have a physical sampling frame, and that's what number 2 is all about in the multi-stage cluster. So I'll talk about that in the next video. Thank you.